A professional analog tape recorder has three heads. Remember, these are really magnets that convert voltage to magnetic flux and magnetic flux to voltage. The tape is pulled past these heads in the following order: erase head, record head, and repro or playback head. On multi-track recorders, the record head also functions as a sync playback head. I'll come back to that in a few minutes. Each head consists of one or more magnets, so a stereo recorder's heads would each have two magnets stacked, one for each track. A multi-track recorder head stack can have as many as 24 magnets for 24 tracks, each of which can be switched independently for recording or playback. The erase head is the first head that tape passes. Its purpose is simply to remove any previously recorded audio signal from the tape before recording. Technically, it randomizes the magnetic particles on the tape, and as the tape pulls away from the erase head, the flux drops down to zero. The tape, or the relevant track on the tape, is demagnetized. As I explained last time, the record head converts the incoming voltage for a particular track into lines of magnetic force or magnetic flux. As the tape is pulled past the head through these lines of magnetic flux, the particles on tape are realigned to correspond to the positive and negative swings of the audio voltage. The realigned magnetic particles retain their realignment when the tape is past the record head, leaving the magnetic representation of the audio wave, which has been permanently applied to the tape. The repro, or playback head, again, works in the opposite way. As the magnetized particles on a recorded tape pass this head, it converts the magnetic flux from the tape back into a varying voltage. This electrical version of the signal is sent on for playback or mixing and processing. As I discussed last time, the process needs to be linear, not only in terms of transfer characteristic and distortion, but also in terms of frequency response. But once again, analog tape recording is not inherently linear in that regard. Due to the nature of the process, the playback response varies with frequency, and so a standard playback EQ curve is applied to all tape recordings by the recorder's electronics. And to keep signals away from the tape's noise floor, the ever-present random hiss, EQ is also applied at the recording stage. Complementary record and playback EQ restores flat response. There are different EQ standards in use in the US and Europe from the NAB and IEC standards organizations. When making EQ adjustments during the regular tape alignment procedure, an alignment tape that adheres to the EQ standard used by a particular tape machine must be used. But again, all this EQ is for the purpose of compensating for frequency nonlinearities that are inherent to the process. The end result should be a virtually flat response. With multi-track recorders, the record head is pressed into service as a playback head for overdubbing. Remember, overdubbing is the process where new tracks are recorded in sync with previously recorded tracks, building up a larger arrangement track by track, a technique widely utilized by one-man band musicians and producers. When doing this with an analog multitrack, there's an issue. The previously recorded tracks the musicians are playing along with are being picked up by the repro playback head, while the new tracks are being recorded via the record head. Since the playback head is physically in contact with a different section of the tape at the time the new recordings, the overdubs, are printed by the record head, those overdubs would be out of sync with the previously recorded tracks. To remedy this, the record head is pressed into service as a playback head. Specifically, in a multi-track head stack, the heads in the stack for the new tracks to be overdubbed are switched to record mode, while the heads for the previously recorded tracks are switched to a special mode called sync mode. This presses them into service as playback heads, and since they're part of the same head stack as the record-enabled heads in that stack, this will ensure that the older playback tracks and the new overdub tracks will be in sync on the tape when the overdub is done. Sometimes the playback quality of these record sync heads might not be as good as that of the dedicated repro head, but it's only a temporary application, and especially on professional recorders, the quality is usually more than good enough. When recording is done, both the older tracks and the newer overdubs are played back via the normal repro head in full quality. Next up, the mechanical components of a tape recorder.